Hello everyone, today we'll be talking about the trapezium rule. Trapezium rule is part of integration. So let's say the curve is like that, okay? So they want you to calculate the area from here to, let's say, let's take this part out, okay? Curve goes all the way here. So they want you to calculate this part to this part. So you can see that this is almost like a trapezium, right? So to do this, they'll give you a coordinate x over here and a coordinate x1 here. So they want you to calculate the area in between here. So it'll be shaded. But that's what normally you'll just integrate. But now the easier way would be a trapezium rule where you divide these parts into equal intervals. So let's say there's 1, 2, 3, 4, 5 intervals. So you have your x1 and your xo. So let's say the formula of the curve or the equation is x squared. They want you to integrate it in terms of, let's change x1 to and xo to b and a. So you put b on top here and a at the bottom in terms of dx. So you want to integrate this. So normally you can do the normal integration way, but another way is, first thing you do is you take you take b minus a and you put it over h. H is the number of intervals, or sometimes they'll say ordinates. Ordinates means how many lines there are. So here it could be 1, 2, 3, 4, 5 intervals, but it's 6 ordinates, whereas 1, 2, 3, 4, 5, 6 lines. So that's the difference. If they say ordinates, you have to 1 minus it to get the number of intervals, but if it's just intervals, just stick with it. So you'll put 5 at the bottom, and then you'll get your value. Okay, so this at the bottom. So next, what you're supposed to do is, so let's just give these numbers for now. Okay, let's just say it is 10 and 5. So 10 minus 5, right? So you'll get 1. That's your that's your ordinate. I mean your h value. So from the h value, you'll use the formula where you do 1 over 2 plus your h, times your h, so times 1, which is this, and then bracket, you will do your first, you have to make a table. So in this table you do this, so there'll be x and y and a line. So let's say, so it always starts with 0. So y would be, if you substitute 0 into here, your y would be 0. So it'll be 0. And then let's say, then add 1, so 1. So since it goes 1, then you keep going. Oh wait, sorry, you start with 5, because that is your x, I mean your a value. So when it's 5 squared, 25. And then it becomes, you add on your h, so 1, 1, 1, 1, 1, so you get 6, 7, 8, 9, and 10. So 5 would be your a value and 10 would be your b value. So finally you would get this, and if you substitute them all in, 36, 49, 64, 81, and 100. So these are the values, these y values are the ones you're going to use. So first you would put 25 plus, you need a times 2 everything in between, because you see there is, so these are values of the lines. So there's only one 25, but then there's, so this intersection is 25 and 36. Then it repeats 36 and 49. It then repeats 49 and 64, and 64 and 81 is repeated. Then 81 and 100. But only 25 and 100 are single values, not double. So you put a 2 bracket 36 plus 49 plus 64 plus 81, and then you bracket that, and then you plus 100 at the end, and that whole thing times this. So in the end you'll get a value. So that value should be that value should be 292.5. Okay, 292.5. So that is your answer. So if you differentiate this and do the same method, you should be able to get the same answer, or an answer similar to it. But it won't be an exact answer, as you know this is not an exact trapezium because it's not an exact straight line. So when you do this, there's some here that is left out. Or if the curve is, let's say, like this, here your trapezium, if it's like this, there'll be some extra space here. So this value won't always be correct, but it's an approximate. Thank you for listening, and I hope you learned a lot from this video. So goodbye.